Hey guys, welcome back to our channel Glitched Velocity. I'm your host Wazahat, and today in this video I'm going to show you how to use custom lighting and how to apply normal maps and specular maps to your animated 3D models in CopperCube game engine with the help of a shader action. As always, you can download the shader action from our website www.𝙎𝙪𝙧𝙘𝙝. So go ahead and download that shader extension from here. Once you have downloaded and installed the shader action to your computer, now open up your CopperCube editor. Let me just maximize it and delete the default cube mesh and the default startup skybox. Now we are going to import our animated model into our 3D editor. So as you might have already seen, I have a bunch of different textures here and some animated models here on my desktop. So I'm going to load one of them in the editor. So go ahead and click import animated mesh, and then I'm going to use doomboss.x 3D model, which is in .x format, which is supported by CopperCube as an animated model. So I'm going to click open here, and it has been loaded without any texture. So I'm going to import some textures for it. So go ahead and click this add button here to import the textures in our texture panel. And I'm going to select diffuse, normal, and specular map for our 3D model. So click open to import it in our texture panel here. And then we are going to apply the texture to our 3D model. So I'm going to go in view and show it, edit and edit properties, and then in materials, and then we are going to apply our texture to our 3D model here. The first one is going to be our diffuse texture, which will go in our first texture slot in the materials tab here. Then we have our normal map, which will go in second texture slot in our material tab here. Then we will have our third texture, which is our specular map, which will go in our third texture slot here. And then you can see it has a really high frame per second or really high speed animation. So I'm going to decrease the speed of the animation by decreasing this frames per second here from 250 to 30 so that it will animate smoothly. And then we are going to supply our shader action in a behavior. So I'm going to go to our root scene node and attach a behavior triggered by events. When a key is pressed, do something, and I'm going to change my key from A to F. And then I'm going to apply a scripted action, which is going to be our shader action, and then search for shader action to use point lights with normal map. And then we will see bunch of different properties, or you can say a lot of properties here. And as always, there are some general shader properties like affecting node, affect all the materials, affecting material, base material type. Then we have shader specific properties like light strength, diffuse color, ambient color, specular lighting, specular texture. Then we have light source 1, light source 2, 3, 4, 5. Then we have light 1 specular color, light 2 specular color, 3, 4, 5 specular color. Then we have light 1 specular strength, 2 specular strength, 3 specular strength, 4 and 5, and like that. So we are going to select our animated mesh as the affecting node. So because we want to apply the shader action to this animated mesh here, and then we will leave this affect all the materials to be on the default value. Then we have affecting material, and we are not going to change it as well. And as we know, we are having a solid texture here, so we are not going to change the base material type as well. And then we have diffuse color, and for now I'm going to use white as the diffuse color, and then ambient color, and we are going to leave it on default value as well. Then we will have this specular lighting. We can turn it off or on. If we want specular lighting, then we can turn it on. If we don't want specular lighting to be enabled, then we can turn it off. Then we have specular texture. We can either use external specular texture by providing a texture name here, or we can supply a specular texture as the third texture for this animated 3D scene or scene node. So as we have already supplied a specular texture, we are not going to put anything in here in the specular texture property here, so we can leave it empty. Then we have light source 1, light source 2, light source 3, 4 and 5, and these are scene node types, so we need to put a scene node in there. And as we want to apply lighting to our 3D model in order to achieve normal mapping and specular mapping, what I'm going to do is I'm going to create some point lights here. So we have light 1. And in order to check the lighting on the 3D model, I'm going to change the lighting type of this model by going in materials tab here and then in lighting from none to dynamic. So now we can see how it will affect the model. So this is how it looks. And now I'm going to clone some lights. So I'm going to clone this and move it here so that the animated model will be lit completely. And I'm going to clone it again and move it here. Do few more clones of the light and move it here. Do one more time. Move it. All right, I think here, or maybe you can say here. So that's it. We have some point lights in our scene, which is affecting our 3D object, which is our Doom boss enemy. Now I'm going back to our shader action. And in our light source, we are going to supply the light nodes we have just added in our scene graph explorer or in our scene. So in light source 1, I'm going to select the light 1. And in light source 2, I'm going to select light 2, then light 3, and light 4, and light 5. And then we have light strength here. We can increase the strength or we can decrease the strength. To get somewhat similar effect of these point lights, we need to use the value about 50 or 40. So I'm gonna use 50 here, or you can say 40 here as the light strength. So all these 5-point lights will be going to use same light strength, which is 40. And it can be somewhat annoying that all of the light source uses same light strength, but different specular color and specularity strength. But yeah, that's it. That's how it works. So let me just test the application by pressing Ctrl F10. And right now, as you can see, there is no normal mapping or no specular highlights on this animated model, and it is using the default lighting setup. But when I press F key, then this model will use the normal map we have supplied as the second texture, and this will use the specular texture as well as a specular map and will have specular highlighting. If I press F, then you will see the lighting has been changed and it has specular highlighting as well. You might not be able to see the specular highlighting because it is so tight that it is barely visible. So I'm gonna decrease the specularity strength here to something like 1, 1, 1, 1, and 1, so that you can see it more clearly. And what I'm gonna do is I'm gonna change the background color to black so that the scene is more visible or the lighting is more visible. So now if I press Ctrl F10 and if I press F now, and you can see how the specularity affects the model. It looks much more shiny. It looks more glossy, or you can say it is more brilliant. I think looks really cool, giving that shiny look to the shell or weapon and toes or metallic look to the 3D model here. We don't have any specularity on the meat or flesh, but we do have specularity on the horns and the shell here. You can say on shoes, or you can toes, not the shoes, and the weapon. So it looks brilliant, isn't it? And We can tweak a bunch of different settings in here. For example, we can change the light color by selecting the point light and going in here and change the light color to something like red. If I press Ctrl F10, then it will use the default light color. So we have supplied light color red to one of our light, and if I press F, then it will use the default light color and affect the material of the 3D model here. We can change it to blue or something else. I'm gonna use blue color here. And if I press F, you can see it has blue color here on this side. And let me just change it back to white and go to our shader action. And then we are going to change the specularity color for some of the light nodes. So I'm gonna change light 2 to light 2 specular color to blue and light 4 specular color to red. See how it will affect the specularity. So if I press F, then you can see there is some blue specularity and there is some red specularity as well in here. So we have red specular mapping and blue specular lights. And it looks really great with these specular texture and normal mapping. What else we can do? We can change the ambient color, something like, green or dark tint of green. And if I press Ctrl F10 and if I press F now, then you can see it gives some green tint or green ambient to the 3D model. We can change it to a bit lighter version of the green. We can pull it up, hit OK, press Ctrl F10 and press F. So it is much more green now and looks great. So we can also change it back to black, and we can change the diffuse color of the 3D model to something else. So we can use yellow here, for example. And if I press Ctrl F10, if I press F now, you can see it is yellow now. The diffuse color of the 3D model is now yellow, and we can change the light color. As I have already told you, we can change the light color, but I want to see how it looks with the diffuse color of the 3D model with the blue lighting. And as you can see, it has not that much effect. So the diffuse color of the lighting will not be seen on this 3D model. Instead, the diffuse color of the 3D model will show here. So you can change the diffuse color for all the lights. You can say all the lights or the 3D model in or shader, but we can also supply individual light diffuse color to all the lights. And we can change the diffuse color to white so that it will use the light diffuse color instead of the model diffuse color. So we can change it to white so that it will affected by the light color. Then we can turn off the specularity, or you can say specular lighting. So I'm gonna turn it off and test the application. Press F so that it will have no specularity but has normal mapping. As you can see, it has normal mapping but no specular highlights. So let me just change it back to white. I don't like blue color. If I press F, then you can see the normal highlights or the normal mapping, and there is no specular highlights. We can turn the specular highlights back on. Going in here to our shader action, then turn specular light back on. And what if we want to turn off normal mapping? So what we can do is we can go to our edit and delete properties, then simply delete this texture to string by deleting it and press enter. or you can remove the second texture slot. And if I press Ctrl F10, go here and press F, and there is no normal mapping or specular highlights to the model, but it is still affected by the custom lighting. So you can see the custom lighting, but there is no normal mapping on this 3D animated model. Let me just put it back here. We are back with the normal mapping and specular highlighting. So specular highlights will only work if you have normal maps applied to your 3D model. So right now we have specular mapping and normal mapping back into the scene. So what if you want specular highlights but don't want normal mapping? Then you can simply supply a plain normal texture here with no bumps at all. Then it will work with the specular highlights and will have no normal mapping on the 3D model. Let me just simply use another 3D model here instead of this Doom enemy mesh here. So I'm gonna move it aside and import this snack FBX file here. And it is loaded. And let me just scale it up to something like 10, 10, 10. A little bit here. And then gonna change the lighting to dynamic. And then we are going to import the textures, diffuse one, normal map, and specular map. And simply supply the textures in the materials slot or the texture slot of the materials tab. And we are good to go. And then we are going to change the shader affecting node from animated mesh 1 to animated mesh 2 so that it will use the snake model here instead of. And as you might have already noticed, it is flipping to different direction. That's because it is using all animation. And I'm going to change this to something like snake wet 3. So this is how it looks without any normal mapping or specular highlights. But if I press F, then you can see how it looks with specular highlights and the normal. Let me just move it here and rotate it so that we can have better view or better lighting. Also, I can increase the light strength here in my shader action, something like 50. And if I test the application now, if I press F, then you can see clearly how the specular lighting is working on this 3D model. It has blue and red lighting, specular highlights. And as you go towards the tail here, it has white specular highlight. And then we have a mixture or blending of blue and red, which is giving us purple or pink color. Let me just change the specular highlight color to white for all the lights. And that's the application now. So I press F, then you can see how it looks really good. We can change the strength, we can change the color, and we can change the diffuse color. We can change the, let me change the diffuse color, something like green, or you can say a dark green, and ambient color to blue, very dark blue. That's so it looks like a green snake with the specular highlighting. It can be used to create variations of your 3D model color. So for example, it has now changed into a green snake instead of yellowish snake. So, yeah, it's pretty good lighting with normal maps and specular maps for your animated meshes. By default, CopperCube doesn't support normal maps and specular highlighting for animated models. You can do normal maps for static models in CopperCube, but you can't do it for animated models. But with this shader action, you can do specular highlights and normal maps with the animated models as well. But there are some limitations of the shader. If you are going to use the shader, then real-time shadows will not work on these models. So they will not receive any shadows if they are using this custom point light shader, and they will not be affected by fog. So fog will not affect these models with custom light shaders. So there are some limitation, and there is a very big limitation, which is that you can use up to 5-point lights only, and you have to manually supply them to the shader action. So suppose if you have more than 5 lights, then the shader will not automatically grab all the lights into the shader memory, but it will instead use only those 5 lights that will be provided in the parameters of the shader properties as the light source. So it will use light 1, light 2, light 3, light 4, light 5 as the base, you can say, as the only light nodes for the object. And your object will not be affected by any of the lights in the scene. Whether it's a directional light, whether it's a point light, it will not get affected by any of them. So it will only use those 5-point lights which will be provided in the shader action. But I think I can overcome this problem or overcome this issue, and will provide a future update to the shader action. But for now, it works pretty well if you are not using so much lighting. You can also tweak the shader or modify the shader to use proximity or something like that to automatically switch the lights according to the position of the 3D model or according to the radius of the 3D model. If this point light gets into the proximity of the snake, then send the data of this light node instead of the light node provided in the shader action to the shader, so that this light node will be used and the previous light node will be ignored. But it can only use 5 light nodes at a time to render on the object. So there is limitation, and then there is this limitation that you have to supply single light strength for all the light. For example, all the light nodes here are using 50 as the light strength, and yeah, that's pretty much it. So this is how you can do normal mapping and specular mapping with custom lights with the help of a shader action. Hope you liked the video. If you enjoyed the video, give it a thumbs up, share it with your friends, subscribe to the channel, and join the Discord channel. Link will be in the description down below. And bye-bye. Have a good day. Bye-bye. Peace out.